Good afternoon. So my experiment's known as hot ice. The hot ice experiment demonstrates an exothermic reaction where a supersaturated sodium acetate solution rapidly crystallizes, releasing heat as it solidifies. This shows how energy is released during bond formation in a physical change from liquid to solid. Some common everyday uses of this knowledge are those heat pads for your hands, sort of like warmers you'll put in your pockets, kind of like gel packs, and even MRE meals for soldiers to heat their food when they don't have access to an open flame. When you mix baking soda with vinegar that is already in the pot, they undergo an acid base reaction, which will produce sodium acetate. And with the water and carbon dioxide gas, which will be the fizzing you see during the experiment, once the bubbling stops, you're left with a liquid containing sodium acetate. That can be concentrated and cooled to then perform the actual experiment, hot ice crystallization. After the demonstration, I will go more into depth about what happened and what actual chemical reactions occurred. But for now, I'm just going to go ahead and just get through with the experiment. I'm wearing all the appropriate gear and my work area is sterilized, so let's go ahead and begin. Okay, so for the first part of this experiment, I'm going to slowly pour about 140 grams of baking soda into about 2 liters of vinegar. And you need to do this slow so you don't get an explosion, since it can be a pretty violent reaction if you were to just dump it in there. So, going really slow. You can see it's already kind of fizzing. That was a lot. Let that calm down. I'll come back with once it's all in. One thing I want to mention quick as well is this experiment isn't the quickest. You do kind of need to take your time, not just pouring the baking soda in the vinegar, but after this we're gonna have to boil it on a low flame, and that can take about an hour. But that'll be the next step. So I kind of will just do this to get rid of the bubbles. It doesn't really harm the experiment or alter it, just to help stop it. But I will come back once it is ready to start boiling. Okay, so now it looks like it's been thoroughly mixed in for the most part. I just went ahead and used a spoon just to kind of twirl it in and make sure it was mixed well. Now, we need to turn up the heat. We'll turn on the flame here, and we'll have to put it on low. And what this is going to do is this will concentrate our solution, because right now the experiment won't really work with just how much liquid we have. So we'll need to concentrate the liquid. So this can take quite a long time. So again, I'll come back when this is done, and we'll know it's done once we see kind of like crystals on the surface of the vinegar and baking soda solution, and that's how we'll know when it's done. So I will come back when I see that. Just gonna do a quick update here. So it's gone down quite a bit, and it's getting thicker, so it's almost there. You can see that the spoon is leaving like a trail. So we know that the solution is getting more concentrated, which is what we want. And it's very small, a little hard to maybe see on camera, but on the rim there, we're starting to see tiny, tiny forms of crystals. And it's already been like, I've been doing this for like 5 hours. It was on low. I had to turn it up just to speed up the process, just being careful not to burn it. But so far, so good. Okay, so I finished concentrating our solution. Slightly yellow tint. Now we're gonna put them in this cooled bath. We're gonna leave them there for about an hour. And in an hour we'll come back and visit this. Okay, so we ran into a bit of an issue here. there is no reaction occurring. So I'm assuming that maybe the solution was not concentrated enough, or perhaps, actually, yeah, that's the only thing I can think of, is perhaps the solution was not concentrated enough. So what's supposed to happen is when you touch the solution, it's supposed to rapidly crystallize, releasing sort of like a bunch of burst of energy. And that was supposed to be an example of an exothermic reaction with your spontaneous crystallization. But it is not occurring. So I'll try another batch. I'll just repeat the same steps that I did previously in this video. And if that doesn't work, then I'll just have to go ahead and move on and at least just show more in detail of what was supposed to happen. Okay, well, I wanted to take a closer look at what I was trying to replicate. I tried doing the experiment again. It didn't work the second time, and it's a very lengthy process, so I'm not entirely sure what I was doing wrong, but maybe I could show you what I was meaning to do by taking a look at the molecular structure of both those ingredients. So on the left is a vinegar molecule, and on the right is a baking soda molecule. So we combine the two in the pot, and what's supposed to happen, so a hydrogen breaks off from the vinegar molecule, and a sodium, hydrogen, and just one of the oxygen molecules is broken free from the baking soda, and this leaves us with carbon dioxide. This eventually gets released out into the atmosphere, I guess, via bubbles as we're boiling it. And then what happens is the sodium ends up attaching itself to the vinegar molecule, and what we have left over here is water. Now this new solution is sodium acetate. Now our goal was to make this new solution, the sodium acetate, stronger, and there is a lot of water. Oh, dropped one. So this is H2O. So there's a lot of water that we need to boil off because we need to concentrate this this solution. So by leaving the solution on the stove, we're boiling off excess water, leaving us with a higher concentration of the sodium acetate. I'm going to do the rest of the video looking at me, but this was my failed experiment. But essentially what was supposed to happen is once you have the concentrated sodium acetate, you're supposed to put it in the fridge and get it right below freezing temperature. And then when you touch it, it crystallizes. You need some sort of it's like really delicate, so you need some sort of trigger to release that stored energy that's within the solution. And as it's crystallizing, it releases heat. So this is very common in the product that you'll see in like those hot packs when you put them in your pocket on a cold day. You kind of like will either crack them or squish them. Usually they're only kind of used once. We used them a lot when I was on the aircraft carrier in the middle of the Arctic. And as it's crystallizing, it heats up, so it keeps your hands warm. But yes, that was essentially my experiment. At least that's what it was supposed to be. If you have any questions or wanted me to explain something further, go ahead and let me know. But for now, that was the video. Thank you. Bye.